Solve the square root of x minus 2 equals 3. I'm going to rewrite this equation where I have a little bit more room. So we have the square root of x minus 2 equals 3. This is a radical equation because it's an equation where there is a variable inside a radical. We know that when we're trying to solve an equation, we usually want to get the variable alone. And here it's a little bit more complicated because the variable is inside a radical. So we want to effectively get rid of the radical. Now on the left-hand side, we have the square root of x minus 2. If we want to undo that square root, if we want to get rid of that square root, the thing that we need to do is we need to square the left-hand side. And we actually have a rule that tells us if we have an equation, we are allowed to raise both sides of the equation to the same power. So if we have some equation, x equals y, then we are allowed to raise both sides of that equation to the same power, and the results will be equal. So in this situation, we want to get rid of that square root, and the way that we can do that is by squaring both sides. So on the left-hand side, if we square the square root of x minus 2, we end up with just x minus 2, because taking a square root and then squaring something ends up canceling out those two operations. And then on the right-hand side, we have 3 squared is 9. Now, to get x alone, we have to add 2 to both sides of this equation. That leaves us with x on the left and 11 on the right. But there is one thing that we have to be very careful with. When we square both sides of an equation, there is a chance that doing that will create an extraneous solution. So we will always have to check for extraneous solutions, meaning we will always have to check our solution in the original equation. So let's check x equals 11. If we substitute that into the original equation, we have the square root of 11 minus 2. Because we've got root x minus 2, and x is 11. So the square root of 11 minus 2 equals 3. Now, when we subtract, 11 minus 2 is 9, so we have the square root of 9 equals 3. And this is true, so that we know our solution is correct. And that means x equals 11 is our final answer. The reason that we might end up with extraneous solutions comes down to the fact that when we use the radical symbol to express a square root, we really use that to mean we want the principal square root, or the non-negative square root. Remember, a positive number will have 2 square roots. If we want the square root of 9, well, 3 is a square root of 9, and also negative 3 is a square root of 9. But this radical symbol means we specifically want that positive square root. And the fact that there are 2 square roots, but this symbol specifies only the positive square root, can potentially cause problems in these situations. So anytime we are squaring both sides of an equation, or we're raising both sides of an equation to an even power, we need to check for extraneous solutions in the end by plugging our solutions into the original equation. We will see examples later on where there are extraneous solutions, so look out for those.